Right, this is the third question. Three particles of mass M1 1.2 kg, M2 2.5 kg, and M3 3.4 kg from an equilateral triangle. That is very, very important. An equilateral triangle of edge length A equal 140 meter. What is the position of the center of the mass of this particle? Now, it's actually very important we draw this diagram. So it's very important to draw this diagram. All right, so this M1, M2, M3. The next thing is to give coordinates. Since it's an equilateral triangle, it means all sides are equal. All right, so for M1, it's actually at the origin 0, 0. While for M2 is at the position of 0 to this point. So for X it is 140, for Y it is 0, it's not having any height. Alright, for this point, now for M3 we need to do some calculation. This is an equilateral triangle, and then from this point, if we trace it down, it should be able to bisect this line, and then when there is bisection, it means that it's half the length. So at this point, X should be 70. It should be at the midpoint. X should be 70. Why for the height? I know many of us will be tempted to say it's 140. It cannot be 140. It's this slanted line that it's 140. So this is what we are having. To calculate the height, we need to use Pythagoras theory to calculate the height. So I had to cut that part out so we can see it very well. So we want to find the height here. So we're using Pythagoras theory. Hypotenuse square equal opposite or adjacent, and then let's say the height square. Let's put this page as h. So how we simplify this? I'll make h the subject of formula. So h square equal 140 square minus 70 square. What happened is 70 square came to this point, so it becomes negative 70 square. So I'm going to simplify it now. All right, this simplification. So the height now is 70 root 3 meter, and if you want to leave it at decimal point, it's fine. So okay, so we don't get confused. This x1, y1, x2, y2, x3, y3. All right, how many particles do we have? We have 3 particles. So xcm will be equal to m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. Right, so all we need is just to substitute the value. Right, after simplifying this, what we have. Okay, let's calculate that of y. The formula will be ycm equal m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. So we simplify by substituting the value. M1 is 1.2, and the position of M1 is at 0 for Y. M2 is 2.5. The position of Y for the position of M2 for Y-axis is 0.2 plus M3 is 3.4, and then the position for M3 at the y-axis is 70 root 3, then over the sum, that's 1.2, 2.5 plus 3.4. So what I'll just do is simplify. Right, this is the value for y3 after simplifying. So it means that the center of the mass, it's xcm comma ycm. These are the coordinates, and then it's now 82.8 meter, comma approximately 58. I'm going to say 58.1 meter. All right, we can actually locate these points in our graph. All right, so x is 82.7. If here is 70, so it should be around this point. Y is 58.1. Okay. Let's say 58 is around, let's say around this point. Remember, we're not drawing according to scale. We're just guessing it should be around this point. All right, so this is the center. So what I'll just do here is just write the coordinates. That's 82.8 comma 58.1, and then I'll just rule a line from here to here to signify that that's distance from the point of origin. All right, looks like this. Okay, so this will be the end of the system of a particle. If you have any question, you can leave it at the comment side below, and please do subscribe. Do click the notification bell to get notified about new topics that will be posted. Thank you very much.